Hello students, today I will be taking you a lecture of big data on the topic of analyzing data with Hadoop. So here are some of the ecosystem components of Hadoop. The first one is yarn. I have already told you in the previous lectures that what is a yarn? It is yet another resource negotiator. And what role does it play? It manages and schedules resources. The function of yarn is to allocate systems resources to various applications running in a Hadoop cluster, ensuring efficient data processing. Now, Hadoop Common is also one of the ecosystem component. Its role is to provide shared utilities and libraries, and the function which it performs is that it contains the common Java libraries and utilities needed by other Hadoop modules. Now, what are the data ingestion tools? Scoop plays the role of facilitating data transfer. Function of Scoop is to transfer bulk data between Hadoop and relational databases. The Flume plays the role of collecting and transporting log data. Function of Flume is to ingest streaming data into Hadoop for processing. Data processing tools are Hive. Hive performs the role of data warehousing and SQL-like querying. Function of Hive is to provide a SQL-like interface for querying data stored in HDFS. Pig performs the role of high-level data processing, and the function of Pig is that it uses a scripting language called Pig Latin for writing data analysis programs. Now here are some data storage tools. First is HBase. The HBase performs the role of non-relational distributed database. Function of HBase is that it stores large amounts of sparse data and provides random, real-time read-write access. Cassandra performs the role of distributed NoSQL database, and it performs the function to manage large amounts of structured data across many commodity servers without a single point of failure. Another kind of data processing tool is data serialization and coordination. First one is Avro. Avro performs the role of data serialization framework. Second, the function of Avro is that it provides data serialization and data exchange services for Hadoop. And Zookeeper performs the role of coordination services. Zookeeper performs the function of managing distributed applications by providing services like configuration management and synchronization. Now, data analysis and visualization tools are, one of them is Mahout. Mahout has a role of being a machine learning library. It performs the function of providing scalable machine learning algorithms for clustering, classification and collaborative filtering. Second is Oozie. Oozie has a role of workflow scheduler. It performs the function of managing Hadoop jobs as directed acyclic graphs of actions. Ambari has a role of cluster management. It performs the function of simplifying the provision, managing and monitoring of Hadoop clusters. In the Hadoop ecosystem, the data formats play a crucial role in storing, processing and managing large datasets efficiently. Here are some common data formats used in Hadoop. First one is text format. Text format can be of a plain text or it can be of CSV type. Now, plain text has a description of simple text files with new line separated records. Usage of text format is that it is easy to read and write but not space efficient and lacks schema information. CSV is common separated values. Description is that CSV text files with comma separated value widely used for tabular data but can have issues with delimiters within fields. Binary formats. The description of binary format is that it has a sequence file. Now, this sequence file is a binary format for storing key value pairs. Usage of sequence file is that it is efficient for MapReduce input-output, supports compression. Avro has a description of data serialization system that uses JSON for defining schemas in binary format for serialization. Usage of Avro is that it supports schema evolution and is used for data exchange between programs. Now, Parquet can be described as a columnar storage format. Its usage is that it is used for efficient for analytics, supports complex nested data structures and enables higher compression rates. Now, ORC is optimized row columnar. Description of ORC can be, it is a columnar storage format optimized for reading performance. Usage of ORC is that it is commonly used with Hive, provides high compression and fast query performances. Specialized formats, RC file or record columnar file. Description combines row and columnar storage approaches. Usage used in Hive for better performance than plain text format. Thrift description data serialization format that supports various programming languages. Usage used for RPC remote procedure call and data serialization. Choosing the right format. How are you going to choose the right format amongst these formats? First one is text format, simple to use but less efficient. Binary formats, more efficient, support compression and schema evolution. Columnar formats, ideal for analytics and query performance. Each format has its strength and its trade-offs. The choice depends on the specific use case, such as the need for compression, schema evolution or query performance. Analyzing data with Hadoop involves several steps from data ingestion to processing and querying. Here's a high-level overview of the process. Number 1, data ingestion. Before you can analyze data, you need to bring it into the Hadoop ecosystem. Tools like Scoop and Flume are commonly used for this purpose. Scoop transfers data between Hadoop and relational databases. Flume collects and transports large volumes of log data into HDFS. Now, data storage. Once the data is ingested, it is stored in Hadoop distributed file system. Hadoop distributed file system provides reliable and scalable storage for large data sets. Data pre-processing. Hadoop offers special framework for tools for processing data. MapReduce is a core component for distributed data processing. It splits data into independent chunks and processes them in parallel. Hive provides a SQL-like interface for querying data. It is ideal for those familiar with SQL. Pig uses a scripting language called Pig Latin for data transformations and analysis. Spark is a fast and general-purpose cluster computing system. It offers in-memory processing for better performance compared to MapReduce. Now, data querying. For querying and analyzing data, Hive is used, which Hive enables SQL-like querying on large data sets stored in HDFS. Impala is a parallel processing SQL engine that provides low latency queries. Drill allows SQL querying on various data sources including HDFS and NoSQL databases. Now, data analysis. Hadoop provides tools for machine learning and advanced analytics. Mahout offers scalable machine learning algorithms for tasks like clustering, classification and collaborative filtering. MLib is a part of Apache Spark. It is a library for scalable machine learning, including tools for classification, regression, clustering and collaborative filtering. Example workflow. First part is data ingestion. It uses Scoop to import data from a relational database into HDFS. Data storage, store the ingested data in HDFS. Data processing, use MapReduce or Spark to clean and transform the data. Data querying, query the processed data using Hive or Impala. Data analysis, apply machine learning algorithms using Mahout or MLib. Visualization. For visualizing the results, you can use tools like Hive, a web-based interface for Hadoop that includes tools for querying and visualizing data. Tableau connects to Hadoop and provides powerful data visualization capabilities. Now, real world example. Imagine you have a large data set of user behavior logs from a website. Here's how you might analyze this data with Hadoop. Number one is that you have to ingest the logs. Use Flume to collect and store the logs in HDFS. Number two is store the data. Store the logs in HDFS for reliable and scalable storage. Number three is process the data. Use Spark to clean and aggregate the logs, identifying trends and patterns in user behavior. Number four is querying the data. Use Hive to perform ad hoc queries and generate reports on user engagement metrics. Number five is analyze the data. Use Mahout to build a recommendation system based on the user behavior patterns. Then number six is visualizing the data. Use Tableau to create dashboards and visualizations of user engagement and recommendations. Now these are some steps to analyze data with Hadoop. First one is that you have to set up Hadoop. You install Hadoop on your cluster. You can use Apache Hadoop distribution or cloud-based solutions like Amazon EMR. Second step is when you upload data to HDFS. Use the HDFS DFS PUT command to transfer your data into HDFS. Number three is write MapReduce jobs. Develop your MapReduce programs in languages like Java, Python or Scala. Number four is execute jobs. Run your MapReduce jobs on the Hadoop cluster using the Hadoop jar command. Fifth step is to retrieve result. After the jobs complete, use the HDFS DFS get command to download the result from HDFS to your local machine. Sixth step is when you analyze result. Now, to analyze result, we will use tools like Apache Hive, Pig or HBase to perform further analysis and visualization. Now, there are tools to enhance Hadoop data analysis. First one is Hive, second one is Pig, third one is HBase, fourth one is Spark. Now, let's study about them in details. Hive. Hive is a data warehouse infrastructure that provides data summarization and ad hoc querying. Pig is a high-level platform for creating MapReduce programs with scripting languages called Pig Latin. HBase is a distributed, scalable, big data store that can host very large tables with billions of rows and millions of columns. Now, Spark is an alternative to MapReduce that offers faster data processing and supports SQL, streaming data, and complex analytics. Hadoop's ecosystem is a vast and continuously evolving, providing various tools and technologies to enhance data analysis. Scaling out or horizontal scaling involves adding more machines or nodes to your existing Hadoop cluster to handle increased load or to process large data sets. This approach is preferred in big data environments like Hadoop since it allows you to achieve higher performance and fault tolerance without the need to invest in more powerful and often more expensive hardware. Steps to scale out Hadoop. First is evaluate needs. Determine why you need to scale out, be it for increased data volume, higher processing speed or better fault tolerance. Number two is add nodes. Physically or virtually add more machines to your cluster. Ensure they have compatible configurations with the existing nodes. Update configuration HDFS. Update the Hadoop configuration files to include the new nodes, core site.xml, HDFS site.xml. Yarn. Update the Yarn resource manager configuration, which is yarn site.xml, to recognize the additional resources. Deploy Hadoop. Install and configure the Hadoop on the new nodes, ensuring they are properly set up with SSH access, Java and other dependencies. Fifth step is to rebalance HDFS. Use the HDFS balancer command to distribute data evenly across the new and existing nodes. Sixth one is the monitor cluster. Use Hadoop's monitoring tools like Ambari Cloud Error Manager or Ganglia to ensure that the new nodes are functioning correctly and contributing to the cluster's performance. Now, these were I just defined you what is scaling out. Scaling out meant to involve adding more machine or nodes to existing Hadoop cluster, right? Which included increased load or process large data sets. Okay. Now, these were the steps to scale out Hadoop. Now, what are the benefits of scaling out? We will be getting to know the benefits of scaling out. The first benefit is that enhanced performance. It distributes the workload across more machines, reducing processing time. Fault tolerance, more nodes mean better data replication and fault tolerance. Cost effective, generally cheaper to add more commodity hardware than upgrading existing nodes to more powerful machines. Flexibility, easier to manage and adapt to changing data processing needs by adding or removing nodes as required. Now let's get to know about some tools for efficient scaling. First one is Apache Ambari. It simplifies Hadoop cluster management by providing an easy to use interface for monitoring, configuration and scaling. Second tool is Cloudera Manager, offers a comprehensive suite for Hadoop management, including tools for adding nodes and managing cluster performance. Ganglia is a scalable distributed monitoring system for high performance computing systems like Hadoop clusters. Now, scaling out ensures that your Hadoop cluster can handle growing data needs while maintaining performance and reliability. Now, Hadoop streaming is a powerful utility that allows you to create and run MapReduce jobs with any executable or system, the mapper and or reducer. This is especially useful if you want to leverage languages other than Java, such as Python, Perl, Ruby, etc. for your Hadoop jobs. Here's a step-by-step guide on Hadoop streaming. First one is prepare your data. Ensure that your input data is in a format that mappers can process. Hadoop typically expects text files with one record per line. Second is write your mapper and reducer. You can write your mapper and reducer in any language. Here's a simple example using Python. This is an example of writing your mapper and reducer using Python. Now mapper, this is a file saved as mapper.py. This is the code. Here you are importing system library for line in sys.std.na words equals to line.strip. Now word is a variable which is holding the function where we are calling the function line.strip.split. For words and words, this is a for loop. Now this is your reducer.py file. Okay, now you can read the code from here. Here what we are doing, we are importing a system library and initially we are current word holds value none. Count of current is 0. Now word equals to word variable is none. Now we are going through a for loop here. Here word and count will contain line.strip.split t1 function. Now count will hold value integer part of count, right? If current word matches the word, then current count will be plus plus. Else, if that is not the case, then you will print current word space current count, right? Now, again, you are updating the value to current word equals to word and current count equals to count. If current word matches the word, what we will do, we will print current word space current count. Now, if you want to make scripts executable, make sure your scripts are executable. Now, how are you going to make sure that? For this, you have to run this command chmod plus x mapper.py reducer.py. This is how you can execute your current script. Now, if you want to run the Hadoop streaming job, use the Hadoop jar command to run your streaming job. Here's an example command. Hadoop jar. First, this is a path you have to copy. Jar /path/2/Hadoop streaming.jar. Input the slash data. Outputs /data. Mapper /path/2/mapper.py. Now check the output. Once the job is complete, you can check the output directory specified in the command. The results will be stored in the 0000 files. Okay. Now example of use cases. First example is log processing, text processing and data transformation. In log processing, we have to analyze server logs filtering specific entries, etc. In text processing, we have to do word count, frequency analysis, etc. In the third data transformation, we will convert data formats, filtering records, etc. Hadoop streaming is very versatile and allows you to integrate your existing scripts into Hadoop ecosystem, making it a valuable tool for big data processing. Now, I will be wrapping up this lecture with this topic, and I hope you understand all the topics. If you still have any queries, you can write in the comment section and I will get to answer your queries. Thank you so much.